Welcome back, guys. This is lesson 14C. I'm just going to do one example for this one. That is simplifying equations in the form of a cos x plus b sine x. So we want to simplify expressions like this. You can see I've got a question here that's written in a similar format. And we know we can simplify anything like this into this form, which is r cos brackets x minus theta, where r is equal to the square root of a squared plus b squared, and tan theta is equal to b over a. And we're going to use this tan theta part here to find our angle theta here for our simplification. So let's jump straight into it. In this question here, let's rewrite it. Cos x minus root 3x. If I just look at this left-hand side, my first step is to simplify all of this, and then I can solve for when this expression is equal to 1. So a is going to equal 1, b is going to equal negative root 3. So therefore, r is going to equal the square root of 1 squared plus negative root 3 squared. That's going to equal the square root of 4, which is going to equal 2. Now, because this is r, and r does stand for the radius, we're referring to trig, so we're thinking of some kind of unit circle, then we do just have like a positive value. We don't necessarily have the negative version because it's like a length or a magnitude of our circle. Once I've got my r value, I now want to establish what theta is. So tan theta is going to be equal to negative root 3 over 1. So that means tan theta is equal to negative root 3. If I think of my exact value triangle, if I think of my exact value triangle that has a root 3 in it, it's going to be my 30-60 triangle or my pi on 3, pi on 6 triangle. And tan is equal to opposite over adjacent. If my opposite is equal to root 3, then theta must equal pi on 3. So in this case, sine's negative. So the quadrant, my sine's negative and cos is positive, is going to make this negative pi on 3. So that's going to put it in quadrant 4. I've got my angle, I've got r. I can therefore say that cos x minus root 3 sine x is equal to 2 cos x minus pi on 3. Because I have this double negative, I can just change that to plus pi on 3. So I've now created a simplified expression. Now let's solve kind of the back half of that question, which is to let this equal to 1. Okay, so that's going to give 2 cos brackets x plus pi on 3 is equal to 1 over the domain of 0 to 2 pi. So if I divide both sides by 2, I've got cos x plus pi on 3 is equal to 1/2. This is going to feel really similar to some of these questions we've already done where we're solving for some kind of cosine function. So that means I'm going to let x plus pi on 3, sorry, I should say. That part is going to be my angle. That's going to equal whatever angle I have for cosine that gives a positive half. So that's going to be negative pi on 3, 5 pi on 3, and also I may as well just include 7 pi on 3. The reason why I feel like it's good to include 7 pi on 3, even though that looks like it's outside of that domain, because I'm adding pi on 3 here. To get a value for x, I need to subtract pi on 3 from everything on my right-hand side. So you can see I've kind of included one value before my domain. So I got this value, which is before 0. This value is after 2 pi. With some of these questions, it can be good to include one either side and see which one of those is going to stick around and which one of those is going to leave. That means x is going to equal, if I subtract pi on 3 from everything, that is going to be minus 2 pi on 3, 0, 4 pi on 3, and 2 pi. This solution is less than 0, so I'm not going to include that. I'm going to wind up with solutions for x being equal to 0, 4 pi on 3, and 2 pi are my possible values for x. So just to summarize what we've done, I've been given some function in the form of a cos x plus b sine x. I've simplified that using the rule that r is equal to the square root of 1 squared plus the negative root 3 squared. That gave me an r value of 2. I found my angle by doing sine over cos and got my angle of negative pi on 3 because my sine's negative, my cos is positive. That occurs in quadrant 4. I've used that to get my simplified expression over here, and then I've solved my equation like I normally do. Just bear in mind, this is not in your formula sheet, so you will need to have some memory. Write this one down because you need to have to remember this one.